This is a quartz crystal. If we apply a mechanical stress to it, it's going to generate electricity. In 1880, two brothers, Pierre Curie and Jacques Curie, discovered that when we apply a mechanical stress to a piezoelectric material such as quartz crystal, it is going to generate electricity. This effect is known as piezoelectric effect. In this video, I'll be going through the lattice structure of quartz crystal, how it can be used to generate electricity when we apply a mechanical stress to it. To generate electricity, there must be a charge imbalance. That is, positive charge must be at one point and negative charge must be at other points. And electrons have to move from one point to another. If we connect a light bulb to it, the light bulb will light up when the circuit completes. Crystal is a substance that is made of atoms and ions that were arranged orderly in three-dimensional pattern. If we look at the structure of the quartz crystal, it is hexagonal in shape and it consists of silicon and oxygen. Silicon is slightly positive, which means that the rate at which it attracts electrons is less than that of oxygen, while oxygen is slightly negative, which means that it holds to electrons more than silicon does. The center of charges of oxygen and that of silicon are at the same place, which makes the positive and negative charges to cancel out each other. But as soon as we apply a mechanical stress to this structure, both center of charges will shift. The positive ions will move up and the negative ions will move down. This creates a charge imbalance and electrons can now move from one point to another. Conversely, if electric current passes through this material, its shape is going to change. The center of charges will separate, which is going to make this material to change shape. We will reverse the polarity of this electric current. This center of charges will coincide and the material will shrink. So if we apply alternating currents to this material, it is going to vibrate. Any material can be a piezoelectric material in as much as it meets some criteria. The first criteria is that the lattice needs to contain polar bonds. This means that there must be atom which has more positive charge than the other atom. If the charges on the atoms of this structure are equal, there won't be a separation of charges. The second criteria that should be met for a material to be considered as a piezoelectric material is that it must lack certain type of symmetry. That is, the atoms should be asymmetrical. Think of it, if the atoms are like this, that is silicon atoms opposite silicon atoms and oxygen atoms opposite oxygen atoms, there won't be a net separation of charges, which makes it not a candidate for a piezoelectric material. Piezoelectric material are very useful since their shape can change when we apply electric current to it. They can be used as a speaker and they can also be used as a microphone since they can generate electricity when we apply a mechanical stress to it. So when we apply a sound wave to a piezoelectric material, it is going to generate electricity with the frequency of the sound wave, and this makes it suitable to be used as a microphone. This material is also used in many electronics. We used it in wristwatches. It is also used in buzzer and other electronics. Quartz crystal is not the only piezoelectric material. DNA is also a piezoelectric material. Your bone is a piezoelectric material, and some ceramics.